Hello guys, we are going to be looking at Southwest Regional Mock Chemistry Paper 1. We are not going to solve till the end of the paper and we are not going to solve all the questions. Now this video was requested by many subscribers of this channel, but because since I basically produce the videos in this channel, I'm not that good in chemistry, so I just prefer to ignore their messages. But since you guys are writing tomorrow, I just thought it wise to kind of do a little revision with this paper. So any answer I'm going to give you, I'm sure about the answer, okay? But if I don't answer a question, I'll tell you, and you give me the answer of that question in the comment section, because I prefer not to give you what I am not sure of. Okay, so any answer I give you, I am sure of the answer, but there are some questions where I doubt, so basically I will not give you a final answer. I might just give you a guide, because I think it's like 6 or 7 years I lastly did chemistry, so I've basically forgotten so many things in chemistry. So I'm basically using just my advanced level knowledge of chemistry to tackle this paper, so you have to bear with me. Okay, question 1. Which of the following is affected when an atom forms an ion? So I think basically here we just have to note the definition of what an ion is. And an ion is basically either a positively charged, an ion could be positively charged or negatively charged, okay? And an ion is formed when an element loses electrons or gains electrons, okay? Not necessarily an element, maybe a compound, all right? Because I think we have in Form 1 we did something like radicals. So when an ion is formed when an element or a compound loses electrons or gains electrons. If it loses electrons, the ion form is called a cation, and if it gains electrons, the ion form is called an anion. Okay, so what is basically affected when an atom what is basically affected when an atom forms an ion is the number of electrons. So question 1 is clearly option D. I hope I got that correct. All right, let's move to question 2. So question 2, which of the following, identify which of the acid-base property of group 4 oxides is correct. Option A says carbon monoxide and silicon monoxide are basic. I don't know about silicon monoxide, but I know that carbon monoxide is neutral, it's not basic, okay? And I know that the oxides of carbon monoxide is neutral and carbon dioxide is acidic. Okay, so option A is wrong, because even though I don't know about silicon monoxide, I'm very certain that carbon monoxide is not acidic, making me to eliminate option A. Now if I go to option D, since I know that carbon dioxide is acidic, I'm very sure it therefore means that option D is also wrong. So the answer should be option C, because clearly it's very certain that lead 2 oxide and tin 2 oxide are amphoteric. They behave both as acids and bases. So it's left for you to check option B here, but I'm very certain about option C. Yes, it's very clear. Lead 2 oxide and tin 2 oxide are amphoteric oxides of group 4. Okay, now question 3, why do transition metals form complexes? Option D is clearly correct, because they have available d orbitals to accommodate electrons. Okay, so that's a basic reason why they form complexes. I can't really remember the explanation to this that was given to us back then in opposite, but I'm certain that it is option D. Now question 4, the empirical formula of vitamin C is CH2O. If its molar mass is 180 basically grams per mole, what is the molecular formula? So I remember what we usually do here is that we have to calculate the relative molecular mass of the empirical formula, and we equate to 180, then we get the value of N, then we replace it back, something like that. So what we have to do is I have to write CH2O, okay, multiplied with N to give me 180. All right, so carbon is 12, so we have 12 plus 2 for hydrogen, then plus 16 for oxygen, everything multiplied by n equal to 180, which means that we have 14 plus 16, 30n is equal to 180. Okay, 30n is equal to 180, which means that n is equal to 6. If n is equal to 6, it therefore means that we are going to have a molecular formula to be just replace now the n with 6. Okay, since you have realized that n is equal to 6, so we just have to replace this n here with 6. Doing that, introducing it into carbon, we are going to have C6. Hydrogen will be H2 times 6, which is H12. Okay, and then oxygen is O6, and I think this is glucose. Yes, glucose or glucose, any of them. So C6H12O6 should be option D. So question 4 is option D. So number 4 is D. Okay, so we are moving to number 5. Which of the following is a property of ionic compounds? Now, what is an ionic compound? An ionic compound is a compound formed from ionic bonding. Okay, I think my definitions might not really be the best, but I'll just try to explain from what I can remember. So an ionic compound is a compound that is formed from ionic bonding, and ionic bonds are formed when oppositely charged ions, when electrons are being shared between oppositely charged ions. So that is an ionic bond. An ionic bond, I think, is an electrostatic force of attraction between oppositely charged ions. Okay, so option A says that they are made up of atoms. No. Option B says good conductors of electricity. Actually, ionic compounds are good conductors of electricity only if they are in solution and if they are molten, that is, they are melted. Okay, so option A is wrong. Option B is also wrong, because option B is saying that they are good conductors of electricity. But generally, what conducts electricity are the ions, which means that those compounds have ionized. Okay, so it is because of the ions, the free mobile ions, that they are going to conduct electricity. So they are not good conductors of electricity on their own. It is only when they are ionized, which means that they are in solution or they are melted, that they become good conductors of electricity. So I strongly believe that question 5 is C. Yes, I strongly believe that question 5 is C. If you think otherwise, tell me in the comment section. Okay, alright, so let's go to question 6. The first 4 successive energies of an element W in kilojoules per mole, ionization energy specifically, are 900, 1758, 14,905, 21,060. From the values, it can be predicted that. So basically, what is the first? Because 900 is the first ionization energy, 1785 is the second, and so on and so forth. So what is the first ionization energy? It's basically the minimum energy required to I think to remove 1 mole of an electron from 1 mole of an element, of a gaseous element, something like that, to form 1 mole of a gaseous unipositive ion, if I can remember very well. So and when you have these ionization energies given to you like this, you have to check where there is the first high jump. So from 900 to 1785 is not really that much. Then from 1758 to 14,000, you see that it is really large, which means that the energy involved in removing the second, because the energy involved in moving the second electron is very high. Okay, so from energy level, from second ionization energy to third ionization energy, the energy involved in that process is very high. And when this happens, we can say that the element has 2 valence electrons. That's 2 electrons in the outermost shell. Okay, so option A is wrong, because option A says has 3 electrons. If we check from 14,000 to 21,000, it's also a little bit high, because it's kind of like 7,000 or 6,000 and something. But we are first of all looking for where is that jump initially maximum. It's basically from the second to the third. So we dwell ourselves on the second. So you have 2 electrons in your outermost shell. That's you have 2 electrons in your valence shell. Okay, so option A is wrong. Now option B says that the third electron is found in the innermost shell, closer to the nucleus. Let me see option C. The element has one electron in outermost shell. Wrong. Option C is wrong because we have found out that you have two electrons in your outermost shell. Okay, let's see option D. The first and second electrons are not in the same shell. No, they are in the same shell, which is the outermost shell. So I strongly believe that it should be option B, but I can't really explain. I can't really give a justification. But with respect to the other options, I strongly believe that it is option B. So you have to tell me in the comment section if I am correct. So it's kind of, you're the one marking my paper. Okay, so but I believe that you're also learning as we proceed. So let's go to question 7. Determine the pressure of a gas inside a box which contains 0.05 mole of a gas in a volume of 8 cm cube at 30 degrees, and I've given us the molar gas constant as this. Okay, so I think here we just have to use PV equal to nRT. Okay, so let me try to erase this. If we use PV equal to nRT, I think we are going to get good results. Okay, if we use PV equal to nRT, because we have the pressure. No, we are looking for the pressure. So what I'm saying is that if we use the formula, the ideal gas equation, PV equal to nRT, okay, my pressure will be equal to nRT divided by V. Now what is N? Number of moles. It is 0.05. So my N is equal to 0.05. Okay, my V is equal to 8 cm cube. Okay, what next again? We have our R as a molar gas constant, and then we have the temperature. The temperature is 30 degrees, but since my molar gas constant is in per Kelvin, I'll need to convert this temperature to Kelvin by adding 273. So adding 273 to 30, I think we get 303 Kelvin. So we just fit into the formula. So I have my calculator with me. I'll just be reading out the values and punching. Okay, so we need to take 0.05, we multiply with 273 plus 30. Okay, then we multiply the answer with R, which is 0.0821. Then we divide the response by V, which is 8 cm cube. We get 0.1555. So it approximates to 0.16 if you are giving the answer to 2 decimal places. So for question 7, I am very certain that option A is correct, 0.16 atmosphere. Now my volume was still in cm cube because of the units of R. R is in cm cube per mole per Kelvin. Okay, so this mole, this N that is in moles here, in fact all the units, the final unit of pressure is going to be in atmosphere. So I'm very certain about question 7 to be A. Okay, now question 8, identify the product when potassium nitrate is heated strongly. I don't think I can remember chemistry of group 1A, so you guys can just read, but I think there's one saying about that the nitrates of group 1 decompose to oxygen and something. Anyways, I don't really know for question 8. Okay, I cannot be revising chemistry again. It's very long, so you guys should tell me the answer to question 8 and you give me the justification. Okay, because it is from there that some people are going to learn. So when you comment, people who are watching will be very interested in getting your own point of view. So tell me what you think about question 8. I have no idea about it. Alright, number 9, a chemist needs 200 liters of 0.5 molar hydrochloric acid. What volume of 12 molar must be dissolved in water to form this solution? Mole concept chemistry. I think here we have to use a concept of dilution. That's a dilution principle. Okay, which says that if a substance is dissolved in water, the number of moles before dilution is equal to the number of moles after dilution. Okay, so let me try to erase this so that we try to solve. And then since we have concentration and volume, we are very much aware of the fact that the concentration is equal to the number of moles over the volume, which means that the number of moles is equal to the concentration times the volume. So concentration initial times volume initial must be equal to concentration final times volume final. Okay, now in this question we have that a chemist needs 200 liters of a 0.5 molar hydrochloric acid. So what the chemist needs is, what is the number of moles of hydrochloric acid needed by the chemist is the concentration times the volume. The concentration is 0.5. okay, the concentration is 0.5, so 0.5, and the volume is 200. okay, now so this is the number of moles that the chemist needs. Okay, now we now have a solution whose concentration is 12, and we need to find the volume of that solution. So your V final is just going to be 200 times 0.5 is 100, and 100 divided by 12 I think should be 8.3333. So approximately 8.3 liters. So if you check the options, option D has to be the right option. Now question 10. So let me just wipe this off. Those who still need the solution, you just have some few minutes to check so that I wipe it off. You can even screenshot. Okay, all right, so let's move to question 10. So we are very certain that question 9 is D. Now question 10, the definition, it is a solution that contains 1 mole of a solid dissolved in 1 liter of a solution. That's a molar solution. That's basically a molar solution. I'm very sure about this. A molar solution is a solution that contains 1 mole of a solid dissolved in 1 dm cube of solution, and 1 dm cube is equivalent to 1 liter. Okay, so that's it for question 10. All right, oh sorry about that, I have to erase this. Let's move to question 11. For the reaction A plus 2B give us C, the following data were obtained. We have 3 experiments, we have the concentration of the reactants, and we have the relative rate of the reactions. Now the reaction is A, first order with respect to B. So let's just calculate the order of this reaction with respect to this reactant. Okay, now if you want to do the calculation, I think it can be a little bit longer, but I think if you go through the fact that the fact of the relationship between concentration and rate. Okay, now let me say, from what I can remember, am I really certain? Anyways, no, I'm not really certain about what I can remember about that fact that if the concentration doubles, then it is first order with respect to this, or I cannot really remember. So I think I can remember how to always calculate this, so I'm just going to do the calculations, but I think it's a little bit longer. Okay, so you have to learn the fastest way, but I think the calculations will help you in paper 2. So we first of all have to write what we call the rate law. The rate equation is the rate equal to the rate constant K times the concentration of the first reactant raised to its partial order times the concentration of the second reactant raised to its own partial order. Then the overall order of this reaction is the sum of the partial orders with respect to the reactant. So it is N plus M. Anyways, now we have that for the first, let us write 3 equations. The first experiment, the rate is 0.01. okay, in fact, let me just call it R1. So R1 is equal to the rate constant. Now the concentration of reactant A in that first experiment is 0.1, but we have to raise it to the power n, and then that of B is also 0.1, then we need to raise it to the power m. Now let's go to rate 2. So the second rate, which according to the equation there, you clearly see that it is 0.04. so this rate 2 is equal to the rate constant is constant. Okay, now the concentration of reactant A is still 0.1 raised to the n, then that of reactant B is now doubled, 0.2 raised to the m. If you go to rate 3, you see that rate 3 is the same as rate 1, so I'm just going to write rate 1 there because rate 3 and rate 1 are equal. So you get the concentration, you have the rate constant first, which is K. Okay, the rate constant times the concentration of reactant A is 0.2, okay, raised to the power n, and that of B is now 0.1 raised to the power m. So these are my three equations. I'll use these three equations to get n and m. Now I see that in the first and second experiments, the concentration of reactant A is constant, so I can divide the two equations, but I'll prefer to take equation 2 divided by equation 1. So if I take equation 2 divided by equation 1, you see that you'll be taking something like 0.04 divided by 0.01, which is just 4, equal to your case cancel, your 0.1 to the n cancels. Now 0.2 to the m over 0.1 to the m is just 2 to the m. Okay, so which means that m is equal to 2. So it is second order with respect to reactant B. Option A is wrong, first order with respect to B. Option B is correct, so that's my option. Second order with respect to B. Okay, so there's no need to be checking about the other options because I'm certain that option B is correct. But you can use rate 1 and rate, you can use experiment 1 and experiment 3. Since the concentration of reactant B is constant, when you divide, your m is going to disappear and you'll be able to see that it is zero order with respect to reactant A. So the overall order is going to be 2 because 0 plus 2 is 2. So with this, I'm certain about this that option B is correct, second order with respect to B. Alright, number 12, identify the compound that produces nitrogen gas as 1 mole of the byproducts when it reacts with sodium nitrate in hydrochloric acid at 5 degrees Celsius. I can't really remember this, but I can give you a clue. You can just go to chemistry of nitrogen containing compounds. Okay, check under the reaction of amide and the reaction of amines. Okay, with this, I think it should be under something called diazotization reaction, something like that. I think with that you'll be able to get the answer, but for now I don't think I have any clue to question 12. So just follow my advice, and again, if you have the answer, you tell me in the comment section. Okay, all right, so let's go to question 13. I think I'll just end in question, I think in question 24, yes, so that then I start back again from question 25. All right, we are moving to question 13. So we have not answered 2 questions, you have to take notes. Okay, so question 13, what is the equilibrium constant expression for the following reaction? So we have ammonia reacting with oxygen gas to give us nitrogen oxide, which is nitrogen monoxide, and water. So what is the equilibrium constant? Since I think these guys are gases, because ammonia is a gas, oxygen is a gas. Okay, so since they are gases, then then the equilibrium constant is called Kp, equilibrium constant for gases. If they were in molar concentrations, it's going to be Kc. Okay, but since I'm seeing just gases, it has to be Kp. Okay, so you just have to know that I think there's one law called, I don't know if it's the equilibrium law or it is Raoult's law. Is it Raoult's law? No, it's not Raoult's law. I think there's one law where we have the definition of the equilibrium constant, but you just have to note that. I think here we just have to note that. Let me try to wipe this off. I think I can remember that law very well. I think it's under chemical equilibrium. They are probably under chemical equilibrium. So if I have a reaction A plus number of moles B to give me reversible to give me C then plus D. Okay, the equilibrium constant K will be equal to, I'll take the concentration of the products. Okay, we are going to take the concentration of the products and we raise it to their stoichiometric coefficients in the balanced chemical equation, and the stoichiometric coefficients are those coefficients I've written in front. So when I write this square brackets, know that it stands for concentration. So concentration of this then divided by that of the reactants. So we have A to the power A, then B to the power B. So that's it. Okay, so in this case you clearly see that it's going to be you see that the product, we have nitrogen monoxide, so it's going to be the concentration of nitrogen monoxide raised to the power 4, okay, times, so the answer is just D. Yes, the answer is just D. You don't even have to check the other options. The answer is D, because it's only D that has the concentration of nitrogen monoxide raised to the power 4. But if you want to conclude this, you have to write concentration of water raised to the power 6, okay, then divided by concentration of ammonia, NH3, raised to the power 4, then times concentration of oxygen gas, everything is at equilibrium, raised to the power 5. Okay, so if you check very well, you see that option D is the best, is the correct option, in fact. So number 13 is D. Now let's go to 14. The pH of 0.001 molar calcium hydroxide solution is, okay, so I think for us to get a pH, we first of all need to get a pOH, because this guy is a base. This guy is a base, okay, and since it is a base, the pH is going to be gotten from its pOH. Okay, so if it was an acid, we'll just get a pH directly by taking negative logarithm to the base 10 of hydrogen ions concentration. But since it is a base, we need to get its pOH, and the pOH is negative logarithm to the base 10 of hydroxide ions concentration. But I want us to know that if I take pH, okay, and I add to pOH, I must always get 14, which means that to get my pH, I'll need to take 14 minus my pOH. But what is my pOH? Negative logarithm of the concentration of hydroxide ions. So all I have to do now, so at the end of the day, you have something like 14 plus logarithm of hydroxide ions concentration. So all we have to do is find the concentration of the hydroxide ions and then just replace it into the formula. So I think we are going to come back to this little. So now you clearly see that calcium hydroxide is a diacidic base, okay, because it releases two hydroxide ions in solution. So let me just try to write the ionization equation of calcium hydroxide. So you have calcium hydroxide. If it is being ionized, we get the calcium ion plus 2 times the hydroxide ions. Okay, which means that 1 mole of this guy, so 1 mole here gives us 2 moles here. Okay, so what is the number now? 0.001 molar. Since both of them are in the same volume, if you want to get the number of moles from the concentration, you just take the concentration times the volume. But since they are in the same volume, it means that 0.0001 moles is going to give me X, which I'm finding. So X is going to give me, just cross multiply, you get 0, you just multiply this answer by 2, you get 0.0002 moles. So this is the number of moles of hydroxide ions, and therefore it also becomes its concentration. Okay, it also becomes its concentration because they are in the same volume. All right, so with this we have that the pH becomes 14 plus logarithm of 0.0002. So let me just do the punching. So I'm punching 14 plus logarithm of 0.0002. I get 10.3. So option C is correct. Okay, option C is correct. So always be vigilant. Whenever you're given a base, you're asked to find a pH, you need to take 14 minus a pOH and to get a pOH you must get a concentration of the hydroxide ions. So you kind of ionize the base and you get a concentration of the hydroxide ions. Okay, so I'm just going to wipe off everything we have here. So we are very certain that option C is correct, 10.3. Okay, now number 15. If the half-life of a substance is 6.7 years, how long will it take for 600 grams of the sample to reduce to 75 grams? Okay, so I think we still need this. Okay, so I think so we need to find, according to the equation, so they have given us a half-life, they have given us the initial amount 600 grams, they have given us a final amount because it's reduced to 75 grams. Okay, so that's the final amount, 75 grams. Now we need to find the time taken for that to happen. So you just have to use nt equal to n0 e to the power negative lambda t, where lambda is a decay constant ln 2 over t half. But since I need t, I'll first of all divide both sides by n0. So I'm going to have nt over n0. Okay, nt over n0 equal to e to the power negative lambda t. Okay, now I'll take ln on both sides. I'll have the ln of nt over n0. Okay, now the ln of e to the minus lambda t just gives us minus lambda t. Okay, so my t is going to give me negative 1 over lambda times the ln of nt. Okay, times the ln of nt over n0 times the ln. I don't know why the pen is refusing to write, times the ln of nt over n0. Now we know that lambda is equal to ln 2 divided by the half-life, and the half-life is 6.7. Okay, now our nt is the amount that is undecayed at time t, and that amount is 75. Okay, and then our n0 is equal to 600. Our n0 is the initial amount at time t equal to 0, which is 600 grams. Okay, so with that 600 grams, so with that we can just fit everything into the formula. So let me just fit and punch. Okay, so we have negative 1 over ln so on 6.7 times the ln of 600 divided by 75. Okay, we have approximately 20.1. Yes, so option A is correct. So option A is correct. So for this question, option A is the perfect option. Alright, number 16. An element has electronic structure 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. State the group and the period to which the element belongs in the periodic table. Clearly, the group is being determined by the number of electrons in your outermost shell. Okay, the outermost shell here is S, so we have 2 electrons in the S, therefore you're in group 2. Now the period is 4. Okay, because let me try to indicate. So you clearly see that this is the outermost shell, 4s2. So it is period 4 and group 2. 2 because you have 2 electrons in your outermost shell, and 4 because that's a number in front of your outermost shell s orbital. Okay, so it should be group 2 and period 4. Group 2 period 4 should be option A. Perfect, option A. So group 2 period 4. Okay, number 17. Identify a property of group 1 and group 2 elements that increases down both groups. I cannot remember this. So this is a third question that we have not answered. So please, I think this chemistry of these alkali metals and alkali earth metals where you have those various properties. Okay, so just try to read. Tell me the answer in the comment section for number 17. Now number 18, the graph that follows shows a spectrometer trace of a sample of neon. Now on calculation, its relative atomic mass is, what's the relative atomic mass of neon? Now without calculating, you could just, okay, you don't enter a formula booklet, but I think you could know for neon, right? Because it's always you can always know for neon. Neon is element number, let's say hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Neon is number 10. Yes, neon is number 10. That's the atomic number. The atomic number of neon is 10. Therefore, the relative molecular mass should be around, it's always kind of 2 times, like averagely it is 2 times the atomic number. So it should kind of be 20, yes, around 20 like that. So option B should easily be correct if you don't know how to solve. But let's just try and solve and see. Okay, so how do I get the relative atomic mass of an element given a graph of relative abundance against the mass per electron ratio? The mass per electron ratio. So the relative atomic mass of this element is just equal to, what I do is that I take the product of the relative abundance and the mass to charge ratio for every case. I add, then I divide it by the sum of the relative abundances. So I'll take 114 times 20 plus 0.2 times wait, let me try to use the other writer. So what I'm saying is that I'm going to take, so my relative atomic mass, okay, is equal to, I'm going to take 114 times 20, okay, plus I'll take 0.2 times 21, 0.2 times 21, okay, then plus I'll take 11.2 times 22, then I'll divide it by the sum of the relative abundances, 114 plus 0.2 plus 11.2. I'm going to have my answer. So let me punch 114 times 20 plus 0.2 times 21 plus 11.2 times 22 divided by 114 plus 0.2 plus 11.2. I get 20.18 as my answer. Okay, 20.18. So option B is correct. Okay, so it means that my initial guess and sentiments were right. So that's what you do. So option B is correct. Alright, so let's go to question number 19. Question 19. A sample of a solution turns Prussian blue when treated with freshly prepared iron to sulfate followed by iron. Please, I don't even know this answer. Number 20. An organic compound with molecular formula C3H6O produces an orange precipitate with 2,4-dinitrophenylhydrazine. Wow, I can still remember this name. And gives a silver mirror with Tollens reagent. Deduce the name of the compound. Okay, so 2,4-dinitrophenylhydrazine is a test for carbonyls. Okay, then I think the silver mirror test, I think is testing, now I don't know, it's now testing if it is an aldehyde or it is a ketone. Yes, an aldehyde or it's a ketone. Now I don't really know if the test is positive, if it is actually an aldehyde or it is a ketone. So the answer is either going to be option A or option C. Okay, because option A is an aldehyde. Aldehyde always gives carbonyl compounds are aldehydes and ketones, and they always give us a positive test to 2,4-dinitrophenylhydrazine. Okay, so the answer is either A or C. Yes, I believe. So now I don't really remember if which of them gives us a positive test to silver mirror. It is either an aldehyde or it's a ketone, but I'm not really sure. So you tell me the answer if it is A or C. I might still be talking and the answer is not A or C, but my from what I can still remember, it should be A or C. So tell me in the comment section. Okay. Now 21. Identify a pair of isoelectronic anions across the periodic table. Now let's first of all forget about the isoelectronic. Let's focus on anions. Anions are basically ions that are negatively charged. Okay, so we need a pair of isoelectronic anions across the periodic table. So it means that any pair I see here, the two of them have to be negatively charged. So option A is wrong. Okay, option B might be correct, option C might be correct, and option D is wrong, because those are cations since they are positively charged. So I'm just left with option B and C to choose. Now let us go to the word isoelectronic. I just think these are ions that have the same number of electrons in their valence shell. All right, so let's go to phosphorus 3 minus. Phosphorus has how many electrons in the outermost shell? It has to be 15. Yes, 15. But let me see: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So fluorine is number 9. Fluorine, neon. I've forgotten the periodic table. Wait, hydrogen, helium, lithium. Wait, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus. Yes, phosphorus is 15. Now phosphorus is 15 and it is in group. Yes, I've forgotten the group of phosphorus. Let me see: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Fluorine is group 7. Neon is group 8. Fluorine, neon, sodium. Magnesium is group 2. Aluminium is group 3. After aluminium is now silicon, which is group 4. Okay, then phosphorus should be group 5, because after phosphorus should be oxygen, which is group 6. Good. So phosphorus is group 5. Therefore, it needs to have 5 electrons in the outermost shell. But since I'm seeing P3 minus, it means that there's lost 3 of the electrons. So it's now left with 2 electrons in the outermost shell. Now fluorine is in group 7. So it has 1 electron in the outermost shell, because you just need 1 to be stable. Wait. Phosphorus is in group 5. No, it's not having 5 electrons because it needs 3 to be stable. Wait. Yes. Phosphorus is group 5. Does it have 5 electrons in the outermost shell or 3 electrons? Because fluorine is in group 7, right? So since fluorine is in group 7, it needs 1 electron to be stable. So fluorine minus has now gained that electron. Fluorine minus now has how many electrons in the outermost shell? It has gained 1 electron because it is minus. In fact, guys, just tell me the answer. I don't know what is wrong with me. So number 21, I'm normally supposed to answer this because this is basic chemistry, but I don't know what's happening. Anyways, tell me the answer. But we are very certain that option A and D are wrong. Okay, option A and D are wrong because I'm seeing some cations there, but we need isoelectronic anions. So tell me the answer of question 21 if it is B or C. We are coming to the end of this video. 22. I say we enter at 24, right? Okay, 22. Select the correct oxidation state of nitrogen in the compound. Now, is the oxidation state of nitrogen in magnesium nitrate -3? Let us see. So let's just call the oxidation state to be X. That of magnesium is plus, so you're going to have 3 times 2, which is 6 plus 2x equal to 0, because the compound is neutral. So X will be -3. So X is -3, right? Yeah, so option A is correct. Let's just check the other options. Option B says -1 in ammonia. So if it is X, you're going to have X. Hydrogen is +3. So you have hydrogen is +1 times it is +3 equal to 0. So it's -3 in ammonia. So B is wrong. This man says +3 in sodium nitrate. So you are going to have that for sodium is 1 plus that for nitrogen x, that for oxygen is minus 2 times 4 is minus 4 equal to 0. So you are going to have x equal to plus 3. It means even option C is also correct. Yes, option C is also correct. Now let's check D. So for D we have 1 for sodium plus x for nitrogen. Now oxygen is minus 2 times 3 minus 6 equal to 0. So x will be equal to plus 5. Okay, so it means that there are two options for question 22 if I'm not mistaken. The options are A as well as C, right? So if I made a mistake, tell me in the comment section. Alright, the last but not the least question: which of the following physical properties correspond to halogen indicated? Fluorine gas, no, it's not reddish brown. I know that bromine is reddish brown, and bromine a liquid? No, chlorine is not a gas. Chlorine is not a liquid, so option B is wrong, because chlorine is a gas, not a liquid. So B is wrong. Now C says bromine liquid, reddish brown. Is bromine a liquid? Because I know that bromine has a reddish brown color. But yes, I think bromine a liquid. I know that iodine. Anyways, I'm supposed to know this answer. It's ordinary level chemistry. I'm supposed to know, but I don't know why I don't know. Anyways, guys, I don't want to give you an answer that is wrong, okay, or an answer that I'm not sure of. So you tell me the answer of question 23 in the comment section, okay? Now, lastly, question 24 for this video: at 20 degrees, the vapor pressure of heptane is an octane at that and that, respectively. An ideal solution contains 50 grams of heptane and 32 grams of octane. What will be the partial pressure of heptane? Partial pressure. I don't know if I can still remember that formula. Partial pressure of heptane should be equal to the mole fraction of heptane times the pressure of the pure component times the vapor pressure of the pure component, something like that, if I'm not mistaken. Now the mole fraction, how do we find mole fraction? I think the mole fraction has to be the number of moles over the total number of moles, okay? So the mole fraction of heptane is equal to the number of moles of heptane. The number of moles of heptane is a given mass on the molar mass. The given mass of heptane is 50, okay? And then the molar mass of heptane is, or let me try to write constructively, okay? Let me try to write constructively, because maybe there are some people that want to copy. I just pray that I get the answer, because I believe that I can still remember this. So it's just a feeling. That's why I want to solve it. So let me erase this. This is our last question. If the video is good, make sure you like the video, guys. You share the video with your friends and you subscribe to the channel. Don't forget to tell me the answers to the questions that I was not able to answer, so that I'm also going to learn. Okay, so from my pre-knowledge, I know that the partial pressure of a component is equal to the mole fraction of that component times the vapor pressure of the pure component. Okay, I think it's something like this. Now the mole fraction of heptane, in this case, the mole fraction is just equal to the number of moles of heptane divided by the total number of moles, which is number of moles of heptane plus number of moles of octane. Okay, now what is the number of moles of heptane? The number of moles of heptane should be given by the given mass. If you check, it is 50 divided by the molar mass. What is the molar mass of heptane? It is C7H16. So let's just calculate. 7 times 12 plus 16 times 1, you get 100. So this man is 100. That's the molar mass. So you're going to get 0.5. Okay, so this man is going to be equal to 0.5 divided by. Now let us find the number of moles of octane, because we need it. Now number of moles of octane should give us the given mass is 32 divided by the molar mass of octane. Octane is C8H18, so we should take 8 times 12 plus 18, that gives us 114. And if we divide, we are going to get 32 divided by 114 gives us 0.28. okay, so since 0.28, it therefore means that my total number of moles is going to be 0.28 plus 0.5, which gives me 0.78. okay, 0.78. So it means that the mole fraction of heptane is 0.5 divided by 0.78, which is 0.64. all right, so my mole fraction of heptane is equal to 0.64. now this is not really the best, 0.64. now the partial pressure of the pure components of heptane, that's a vapor pressure, was given to us as 473 kilopascals. okay, so what does it mean now? What is now going to be my vapor pressure? So my vapor pressure of heptane will be, the partial pressure of heptane is going to be 0.64 multiplied by 473 kilopascals, because all the results are in kilopascals. So we just take this answer and we multiply it with 473. We are going to get 303.2. wow, I finally got it. I was very sure that I could solve this question. So 303.2 kilopascals. okay, voila. So option B should be the right option. Right, option B should be the right option. That's our right option, option B. Okay guys, so we have come to the end of the first segment of this video. okay, I'm actually, today is Monday, so you guys are writing tomorrow. So as we finish watching this video, just stay tuned while waiting for the next video. Let me see. Let me just do 25. Yes, let me just do 25. Determine the EMF of the cell. In fact, in this case, just take the highest minus the lowest. So just take 0.99 minus negative 0.403. The answer must end with a 2. Alright, and it has to be positive. So the answer is B. Yes, I'm very certain. Now select which can exhibit geometrical isomerism. You have to be an alkene. okay, it has to be cis and trans. Let me just try to draw this option D like this. You have carbon double bond to carbon. Now on the first carbon there is hydrogen and there is CH2. yes, and then on the other carbon, no, I don't think this option Z can exhibit cis and trans. I don't think. So I suspect, let me suspect again. I suspect option B. Let me try to draw option B. We have carbon double bonded to carbon. Now the carbon on the other side has an H and then has the carboxylic COOH, and then the carbon on this side has an H and also has COOH. good. So this is the trans isomer. okay, and then for the cis isomer, we'll just make sure that COOH is on the same side. So yes, option B has to be correct. All right, no, I cannot. These other questions, no guys, we are just going to end here. I don't know how lengthy this video is, but we are just going to end here. So see you guys in the next video. Make sure you tell me the answers to the other questions that I was not able to answer in the comment section.